In our last section, we're going to be using the factorials and Pascal's triangle to expand some binomials. So let's start with our factorials in number 31. 12 factorial over 7 factorial. So we're going to get an idea of what each factorial looks like and see what we can cancel before we evaluate. In our numerator, 12 factorial would mean 12 times 11 times 10, all the way down to 1. And in our denominator, 7 factorial would be 7 times 6 times 5 times 4, all the way down to 1. Since this is all multiplication, we can do some canceling. We can cancel 7 through 1 in the numerator and 7 through 1 in the denominator, leaving us with 12 times 11 times 10 times 9 times 8 in our numerator. That's all we need to do. And that leaves us with 95,040. Number 32, dealing with numbers, 10 factorial over 9 factorial. So 10 all the way down to 1. And then in our denominator, same idea, all the way down to 1. And again, we're looking for what we can cancel, which would be everything except for that 10 in the numerator, and that's our final answer. Now, factorials with binomials. So we are going to use the same approach, write these out by decreasing by one integer every time, and see what we can cancel all the way down to 1. So in our numerator, a plus 4 factorial would be a plus 4 times a plus 3, a plus 2, a plus 1, and all the way down to 1. Writing out our denominator, a plus 2 factorial. So we can see where the repetition is. We're going to cross off these terms in the numerator and denominator because it's all multiplication, leaving us with a plus 4 times the quantity a plus 3. Final answer. 34, a minus 1 factorial would be a minus 1 times a. Oh, sorry, nope. Going the wrong direction there. A minus 2, a minus 3, so on and so forth, all the way down to 1. And in our denominator, a plus 1 times a, there it is, times a minus 1, a minus 2, a minus 3, so on and so forth, all the way down to 1. Cross off our common factors, which would be everything in the numerator, and a minus 1 all the way down to 1 in our denominator. And our final answer is 1 over the quantity a plus 1 times a. All right, Pascal's triangle. Always start with a 1, put a couple 1s on the other side, then add 2. And the second line would represent the coefficients of what happens when we square a binomial. And then we keep going. 1 plus 2 is 3, 3, a couple of 1s on the end. 3 plus 1 is 4, 3 plus 3 is 6, 4, a couple 1s on the end. And here's our 7th row. 15 plus 6 is 21, 6 plus 1 is 7, and 1. So each row is a binomial to a higher power. Here's our 4th, 5th, 6th, and last our 7th row. All right, we're going to use that in our very next problem. As you look at number 36, it says we are going to take 4x plus 3 and raise that to the fifth power. So we're looking for the fifth row of Pascal's triangle, which is 1, 5, 10, 10, 5, 1. And these will be the coefficients of our terms as we expand. So let's start with that 1 for our first term. And as we expand, all of our exponents must add to 5. So we're going to take that first term, which is 4x, and raise that to the fifth power, times our second term, 3 to the power of 0. 5 plus 0 is 5, so we're good there. Then our next coefficient from Pascal's triangle, which is 5, we're going to decrease the power on the first term of our binomial by 1 and increase the power on the second term of our binomial by 1, and then 4 plus 1 still equals 5. Our next coefficient, which is 10, first term decreased by 1 to 3, next term increased by 1 to 2. 3 plus 2 is still 5 for our exponents. Our next coefficient is 10, 4x squared now, 3 to the power of 3. Looking at those exponents, 2 plus 3 is still 5. Our next coefficient is 5. 4x is now raised to the power of 1, and 3 is raised to the power of 4. And then our last coefficient of 1, I think I can squeeze it on here, 4x to the power of 0, and 3 to the power of 5. Oh, sorry, hope you can see that. Couple of things I'm going to cross off before I start expanding. Anything to the power of 0 is just 1. So I can cross this term and this term off because they're both raised to the power of 0. And before I get my final answer, to make sure we do everything correctly, I'm going to leave my coefficients from the triangle out there, and I'm going to focus on what happens when I raise each of these terms to a particular power. So 4x to the fifth would give us 1024x to the fifth. We don't have to do anything with that 3 because it was raised to the power of 0. In the next term, 4x to the power of 4, this is 256, x to the fourth, and then that's also going to be multiplied by a single 3. There's our 10. 4x cubed gives us 64x cubed, and then 3 squared gives us 9. 10. 4x squared would give us 16x squared. 3 cubed would give us 27. And then 5 times our 4x to the power of 1, and then 3 to the power of 4 would give us 81. And lastly, 1 times 3 to the fifth power, which is 243. So now within each term separated by addition, we're going to multiply the coefficients and then tack on the x to whatever power we have. And our final answer, doing that multiplication, would look like this. In the next term, sorry about that, we're going to do 5 times 256 times 3. So the total of our next coefficient is 3,840, and we have x to the fourth. In our next term, 10 times 64 times 9. Ten times 16 times 27. 5 times 4 times 81. And 1 times 243. And that is the full expansion of 4x plus 3 to the fifth power. On to 37. Similar, we are taking 2x minus 3 and raising that to the fourth power. So we're looking at the fourth row of Pascal's triangle, which has coefficients of 1, 4, 6, 4, and 1. And as we evaluate our expansion, 2x will be the term that we raise to the fourth power first. And then because this is minus 3, we're going to be substituting negative 3 as we go. So make sure you use the negative with that 3. We're going to begin with our coefficient from Pascal's triangle, which is 1, and we're going to take that first term and raise it to the fourth power. And because our exponents have to add to 4, that means negative 3 will be raised to the 0 power. We can put a plus in there, and our next coefficient from Pascal's triangle, which is 4, 2x to the third power. So we went down by 1. And then for our second term in the binomial, that's going to go up by 1. And check your exponents there. 3 plus 1 is 4. Sum of every set of exponents in this expansion has to be 4 as we first expand with the triangle. Our next coefficient is 6, 2x squared, and then negative 3 squared. 2 plus 2 is 4. 4 is our next coefficient. 2x to the power of 1, negative 3 to the power of 3. 1 plus 3 is 4, and our last coefficient is 1. 2x is now to the power of 0, and negative 3 is to the power of 4. And I'm going to approach this like I did the last problem. I'm going to work on the exponents all the way through and then multiply the coefficients. Oh, but one thing I want to do first, I want to get rid of anything to the power of 0. So let's cross these two things off. So they are just 1. 2x to the fourth would give us 16x to the fourth. Plus, there's our coefficient of 4. 2x cubed would give us 8x cubed, and then we're still going to multiply by negative 3. Plus 6, 2x squared would give us 4x squared. And then we're going to square negative 3, which is 9. Plus 4 times 2x to the power 1, so that's just 2x. Negative 3 cubed gives us negative 27. And then plus 1 times negative 3 to the fourth, which is 81. So now we're going to multiply all of our coefficients within each term separated by addition and tack on our variable. So our first term is 16x to the fourth. Our next term is going to be negative because we're multiplying 4 times 8 times negative 3, negative 96x cubed. Our next term is 6 times 4 times 9, which is 216 with an x squared. Next term is negative because it's 4 times 2 times negative 27, negative 216x. And our last term is positive 81. And that is the full expansion of 2x minus 3 to the fourth power. So in our last 3 problems, we're going to use a combination of the patterns we saw here in Pascal's triangle to find specific terms. So here we're using combinations, or you could find the 9th row of Pascal's triangle and count over till you found the 7th coefficient. But a quicker way to write this, for the 7th term in the expansion of 7x plus 2y to the 9th power would be, sorry, that's not the symbol I wanted, got a little quick there. To do 9 combination 6. And we know that our exponents must add to 9. So in our first term, it's going to be 7x to the 9th power, and then 8th, 7, 6, 5, 4, 3. In the 7th term, 7x will be raised to the 3rd power. And because our exponents must sum to 9, 2y will be raised to the 6th power. So going to our calculator and doing our combination 9, choose 6 gives us 84. Then we're going to cube 7x to get 343 x cubed. And then 2y to the 6th power gives us 64y to the 6th. And to get our term now, we're going to multiply our coefficients. 84 times 343 times 64 1,843,968 x cubed y to the sixth is our seventh term. As we find the fourth term of 2x minus 7 to the fifth power, we can look at the fifth row of Pascal's triangle and count over to the fourth coefficient, or we can do 5, choose 3. We know that the exponents in each term of the expansion must add to 5. We would start with 2x to the fifth power, but we're all the way down to the fourth term, so let's count down 4 times. 5, 4, 3, 2. So in the fourth term of 2x minus 7 to the fifth power, 2x would be squared. We know our exponents must sum to 5, so that would mean negative 7 is going to be raised to the third power. 2 plus 3 is 5. So 5, choose 3, or from Pascal's triangle, we get our coefficient of 10. 2x squared gives us 4x squared. Negative 7 to the third power is negative 343. Now we're going to multiply over all of our exponents. 10 times 4 times negative 343. Negative 13,720 with an x squared is our fourth term. And our last problem, finding the coefficient of the x cubed term within the expansion of 2x minus 1 to the eighth power. So let's count this down. We're going to use either the eighth row of Pascal's triangle, or we're going to use combinations. We're going to be looking for where x cubed is in that eighth row. So our first term would have 8 x's. Our second term would have 7 x's. Our third term would have 6 x's, and so on and so forth. So by the time we count down to x cubed, we are at our sixth term in the eighth row of Pascal's triangle. Or we can do, sorry, wrong symbol again. 8, choose 5 for our coefficient from Pascal's triangle, since we know that's the sixth term. And we have x cubed because 2x has been raised to the third power. And that means negative 1, our other term in the binomial, must be raised to the fifth power because our exponents must sum to 8. So 8, choose 5 gives us 56. 2x cubed would be 8x cubed. And then negative 1 to the fifth is going to leave us with a negative 1 here. So we have a negative coefficient. All multiplied together, 56 times 8 times negative 1 gives us negative 448 x cubed. But this only wants the coefficient, so our final answer is negative 448.